Welcome to Study Loop.
All right. So we've got to consider vanillin acetate, um, and then how it responds to a variety or two reducing agents. So vanillin acetate has the following structure. Great. Now, I think it'll be useful if we sort of talk about the functional groups that vanillin acetate has before we start talking about the reducing agent. So let's just identify that we've got an aldehyde here, we've got a methoxy, and we've got an ester. Okay, so just right off the bat. Now we've got to talk about sodium borohydride and lithium aluminum hydride, and what the differences between these are. These are both reducing agents. However, one is significantly more powerful than the other. That is, lithium aluminum hydride is a more powerful reducing agent. So the classic example of the power of lithium aluminum hydride is that it can reduce aldehydes, as pretty much all reducing agents have, but it can also reduce ketones, it can reduce carboxylic acids, and it can reduce even esters. Now, in terms of reactivity, this is decreasing decreasing react. No, sorry, this is going to be confusing. I should just why talk about decreasing act. Yeah, okay. So most reactive, least reactive. So aldehydes are more reactive and less stable than ketones, carboxylic acids, and esters, which means to reduce them, you need a more powerful, to reduce these less reactive carbonyl functional groups, you need a more powerful reducing agent. Lithium aluminum hydride can do it all. Sodium borohydride, not as powerful a reducing agent, can only reduce aldehydes, and it will reduce them to alcohols. So if you were to react vanillin acetate with sodium borohydride, we'd see reactivity here. This aldehyde would get reduced to an alcohol. But if we were to react this molecule with lithium and aluminum hydride, both the ester and the aldehyde would become reduced to alcohols. So the products of those would look something like this. With sodium borohydride, we would expect this aldehyde to become an alcohol. This methoxy would be untouched. And then this, what used to be a ester, would simply become oxygen, and then we would have also generated some methanol. However, if we reduced vanillin acetate with sodium borohydride, this part of the molecule would remain the same. The methoxy would still be here. We just have this alcohol. So that's the difference between lithium aluminum hydride and sodium borohydride. Finally, the precautions that should be taken with reducing agents is that these reactions are often very exothermic. So reducing agents are strong, powerful chemicals. Their reactions are often exothermic, so these should be handled with caution. In addition, they need to be separated from oxidizing agents. So any oxidizing agent needs to be kept far away from reducing agent. Because when oxidizing agents meet reducing agents, which are both powerful enough to oxidize or reduce things that otherwise wouldn't be reduced, they come together and make very, very exothermic reactions that are, often explosive or generate fire. And this is in addition to the fact that sodium borohydride and lithium aluminum hydride are highly toxic and shouldn't be ingested or touched or gotten into your eyes. But the very specific caution is to keep them away from oxidizing agents.